Okay, so we're talking about radical equations. So when you have a square root or a cube root or a fourth root, you have an equation involved with the equal sign, kind of like this one right here. So what do you do to both sides to solve? Well, the opposite of square rooting something would be to square something. You can't square just each term. You have to square both sides, so the whole side. So if there were two terms, you would have to square two terms, as in the whole side, which might involve foiling. So we get x equals 16. Not plus or minus, it's just x equals 16. The square root of 16 is 4. You can plug it back in to check and make sure it works. Not a bad idea to do that in this section, especially because sometimes we get answers that don't work out very well. Well, let's try this. So let's square both sides. We get x equals positive 81. If you put that in, if you plug that in to check, always check your answer. You'll see that this doesn't work. Even though we didn't make a mistake when solving it, that's called an extraneous solution. If you think about it, how could a square root be equal to a negative number of any kind? Square roots are always positive, so they can't be equal to negative. We could have just not even squared both sides, just said, there's no solution. There's no way this is possible. A square root is always positive. It can't be negative. There's not going to be a real solution. But if you just solve it using the method that we have, squaring both sides, you might think there's a solution, but there's not. There is no solution to this problem. So that particular solution is called an extraneous solution, which is not really a solution at all. Another thing you need to be careful on is isolate. So before you kind of like square both sides, let's get the other stuff on the other side. Let's get the square root. So we're going to subtract 3 here. So square root of x equals 2. Now we're going to square both sides. So we get x equals 4. Not a bad idea to check it. Square root of 4 is 2. 2 plus 3 is 5. That works. Square the whole side. That's the other thing. Make sure you know. So this one, let's try to isolate this. So I don't like that. It's got a lot going on. So we've got to get the 3x over to the other side. So we get negative 5 square root of x equals 2 minus 3x. I guess we divide by negative 5. Wow. So divide by negative 5. I'm going to divide each term by negative 5. So we get a lot going on in this one. So square root of x equals negative 2/5 plus 3x over 5. And that's a binomial. So when I square both sides, this is where you have to be careful. I said, be careful if you have a binomial there. You're going to have to FOIL that guy, right? So x is going to equal, I'm just going to write it out so we can see it. It might be hard to do in our heads. So we're going to FOIL that with itself, right? And let's see what we get when we FOIL it. So first outside, inside last. So first times first would be positive 4/25. Outside would be minus 6x over 25. Inside would be minus 6x over 25. And last would be, so let's see, 9, so plus 9x squared over 25. To get rid of the 25, or at least to make it less fractions here, let's multiply both sides by 25. So we get 25x equals 4 minus 12x plus 9x squared. Let's kind of organize this. Let's get the 25x over to the other side. So 0 equals, I would write the first term first, so 9x squared minus 25x is minus 37x here, plus 4. I don't think there's a common factor there that we can take out, so we're going to try to factor this. Let's see what happens. Trying to see if this will work. Okay, so let's do the AC method. So AC is 9 times 4 is 36. Factors of 36, they add up to negative 37. If they're both negative, that would work. So I'm going to break up that middle term. I'm going to write minus 36x plus negative x plus 4. And we're going to solve this guy. So pull out the GCF. So that would be 9x times x minus 4 plus, pull out the GCF of -1. I want that leading coefficient positive. I like that. Phew, this does work. So 9x minus 1, x minus 4. Wow, this problem's a long problem, isn't it? So we set each one equal to 0. We get x equals 4. You can do that one in your head. That's one of our solutions. We get 9x minus 1 equals 0. So 9x equals positive 1. So x equals 1/9. And because x was underneath radical, it's a good idea to check your work. So let's see if 4 works here. So we plugged in 4, that would be 12 minus 5 times 2. Square root of 4 is 2. So 12 minus 10 is 2. That works. Plug in 1/9. Maybe 3 times 1/9 is 1/3. Minus 5 times 1/9, the square root would be 1/3, I think. Equals 2. Let's see. It's positive 1/3, right? 1/9. Yeah. Okay. So 1/3 minus 5/3 is 2. Let's see. So it's negative 4/3 equals 2. I don't think that works. All right. So one of these answers is extraneous. So we just have one answer. X equals 4 would be correct there. What do you do with cube roots? So the opposite of cubing side, again, the whole side has to be cubed, would be putting to the third power. That's the opposite of cube rooting, would be third power. So on the left, that's nice. You get 2x minus 5 equals 27. Add 5, so 2x equals 32. Divide by 2, get x equals 16. You don't have to check your work. It's not a bad idea. It's never a bad idea to check your work. But the reason you don't have to check is because you can't get an extraneous solution when it's a cube root. You can with square roots or even root, but not with odd roots. So if I check this, 32 minus 5 is 27, cube root of 27 is 3, it does work. You can check it. It's not a bad idea, but you don't have to check it. There's a difference between those two things. So this one, let's move this over to the other side first. So we get 5x minus 4 to the 1/2 equals x. We're going to put both sides to the second power. That should get rid of that 1/2 power. So now we have 5x minus 4 equals x squared. Move those two terms over to the right-hand side. So x equals x squared minus 5x plus 4. I think that does factor. So x minus 1, x minus 4. So x equals 1, x equals 4. Not a bad idea to check it because, again, this is square root in disguise, right? That's the square root of 5x minus 4. So if I plug this in, I get 5 minus 4 is 1, square root of 1 is 1, 1 minus 1 is 0. That works. 20 minus 4 is 16, square root of 16 is 4, 4 minus 4 is 0. That works. So both of those work. Again, not a bad idea to check your work in this section. And those are both real solutions. Move that over to the other side first. So we get 7x plus 6 to the 1/2 equals 9 plus 4x to the 1/2. Put both sides to the second power. That's not bad. 7x plus 6 equals 9 plus 4x. Get all the x's on the same side. Get all the numbers on the other side. X equals 1. Let's just double check that it works. 7 plus 6 is 13. The square root of 13 minus square root of 13 is 0. That works. Because if they're square roots, you have to check your work. Let's just double check, see if there's another problem down there. There is. So in this one, this would be kind of a neat one. You can put both sides to the reciprocal power. So this would be 2/3 power. And so here, power, you multiply, you get 6, which is 1. So x plus 4, it's really nice, actually, equals the cube root. So this you could write differently. You could write this as the cube root of 8 to the second power. So cube root of 8 is 2. 2 to the second power is 4. That's nice. Subtract 4, you get x equals 0. Just make sure that works. Yep, that works. You can always plug it in to make sure. For both sides, this was not too bad, actually. It's kind of a welcome relief. X plus 5 equals 4. Subtract 1, x equals -1. Not a bad idea to check it. -1 squared to 4 is 2. 2 is not equal to 2. That is an extraneous solution. There is no solution. If you were smarter, you might have figured out, like, hey, square root is equal to a negative number. That's not possible. I don't even have to work this problem. There is no solution. So sometimes you'll see those shortcuts. But if you check your work, you'll catch your extraneous solutions there. So that's kind of nice. That's it. We have a couple extra minutes. Let's do the PSAT today. So cost of long distance call is $1.05 for the first minute, 15 cents for each additional minute. What is the cost of a 15-minute call? Go ahead and try to work this. So you could do this a couple different ways. You could take the answers and plug them in if you wanted to. That's one way of doing this. So you could say, let's pretend the answer is 315. So if that was the case, you want to subtract, so 315 minus the cost of the first minute, which is 105. And so we get $2.10 left over. Let's divide that by 14. So let's see, 210 divided by 14, because there's 14 minutes left over, is 15 cents. Yeah, that looks right, doesn't it? 15 cents for each additional minute. So I think that is accurate. You know, there are other ways of doing it. You could probably set up an equation too, but that'd be one way of going.